And welcome to today's math class, Ace Math with Joy. So today we're going to be looking at logarithm part 1. All right, so this is another fundamental topic in math. So whether you're preparing for WAEC, NECO or JAM, this topic is for you. So now there's a topic you need to learn very well first of all before logarithm, and that is indices. So if you haven't seen my video on indices, please do well to watch it so that you can understand logarithm better. So at the end of this video, you should be able to know the definition of logarithm, connect indices to logarithm, state the laws of logarithm, and apply them in solving questions. So I want at the end of this video for you to confidently pick up questions from WAEC and JAM or wherever that has to do with the laws and application, and then tackle them with confidence. Okay, so let's roll. First of all, what is logarithm? That is where we start from. Now recall that in indices we said that if x is raised to the power a, it gives a value y. This x is the base, this is the exponent or the index, and then this is the value you get when x is multiplied a number of times. Now, what is logarithm? Logarithm tells us the exponent or the power to which a number must be raised to get another number. All right? So logarithm is focusing on the exponent to which this base x must be raised to get a value y. So what does that tell us? It tells us that logarithm focuses on the exponent. All right? So having known the definition of logarithm, how do we connect indices to logarithm? Now, having known that logarithm focuses on the exponent or the index, it means that if this x is raised to the power of a to get a value y, it means that the log of y in base x is equal to a. Now, I want you to compare these two. The relationship between these indices and the logarithm is that log is the inverse. Log is the inverse operation of indices. Now, if you look at these two, you will see that x is the base here and it remains the base here. Okay, so x remains the base. Now, what changed? The exponent. In logarithm, the exponent becomes the value. Okay, so in logarithm, the exponent becomes the value because that is our focus. All right. So very quickly, before we look at the laws and their application, let's see how to convert expressions in index form to log form. So convert to log form. Convert to log form. The first one I have 9 raised to the power of 2 to be equal to 81. The second one I have 49 raised to the power of 0 to be equal to 1. All right, for us to be able to convert this to log form, you would discover that they are already in their index form. So 9 will be multiplied 2 times to give us 81. So if we are to express this in log form, it would imply, remember, if you look at this index expression, 9 is the base, right? So we are saying that 9 remains the base in logarithm. All right? Okay, so we'll have the log of 81 in base 9 to be equal to 2. So for this number 2 or number B, 1B, we'll have the log of what? The log of 1. 49 remains the base in base 49 is equal to 0. Okay, Now, what if you have expressions given in log form and you are to convert to index form? Convert to index form. So now, what if we have expressions in log form and we are to convert to index form? What happens? Now remember, this is your base, whether it is in log or in indices. So we start with the base. 2 to the power of what? Remember we said logarithm focuses on the exponent. So this exponent is this. So 2 to the power of 5 is equal to the value 32. Did you see that? As simple as ABC. So for this one, this remains the base. 1 over 2 to the power of 3 is equal to 0.125. Now, what does this example 2b tell us? It tells us that we can actually have a fraction as a base. So the base must not be a whole number. Is that clear? All right. So now, before we proceed to So what does this example 2b tell us? Example 2b tells us that we mustn't have, the base mustn't be a whole number, all right? So we can actually have a fraction as our base, just as seen in this example, all right? So now, before we go into the laws of logarithm, could you please attempt these two questions for me? Please let me know. Now, if you're done with that, we quickly move to the laws of logarithm. So we're going to be stating the laws, after which we'll pick a few wire questions and then apply the laws on them. So the first we have, if you're conversant with the laws of indices, you easily flow with the laws of logarithm, which is one of the reasons why you need to go and watch the video on indices. So we have the product or the multiplication law. Now this law states that if I have the log of m times n in base a, that it is the same as the log of m in base a plus the log of n in base a. All right. So if I have the log of m times n in base a, it is the same thing as, I can actually add, provided they are in the same base. Now, if you go through past questions, you might see expressions in this form. So you can actually convert to this form to be able to simplify or evaluate as the case may be. So the next law, we have the quotient law. Now, this quotient law is saying that if we have the log of m over n in base a that we can subtract. Are you seeing the similarity between these and indices? Minus the log of n in base a. Okay, so the next law we have the multiplication law. Now this law states that if I have the log of m times n in base a, that it is the same as the log of m in base a plus the log of n in base a. All right. So if I have the log of m times n in base a, it is the same thing as I can actually add, provided they are in the same base. Now, if you go through past questions, you might see expressions in this form. So you can actually convert to this form to be able to simplify or evaluate as the case may be. So the next law, we have the quotient law. Now this quotient law is saying that if we have the log of m over n in base a that we can subtract. Are you seeing the similarity between these and indices? Minus the log of n in base a. Okay, so the next law we have the log of 1. The log of 1. Now this law sounds funny, right? From the name it sounds funny, the log of 1. Now this log of 1, remember in indices we said that anything you raise to the power of 0 is 1, right? So if I am to rewrite this in log form, what would that be? It would be that the log of 1 in base b is equal to what? 0. Did you see that? So that is to say that anytime you see a question that has to do with log 1 in any base, if it likes, let it be in base 1 million, provided it is log 1, the result will always be 0. All right. So connecting it to indices, you've seen why and how it is that way. Okay, so the next law, we have log of the base. Log of the base. Now this law is saying that any log in its base is equal to 1. How? Now remember in indices that if I have b raised to the power of 1, that anything raised to the power of 1 remains that value or that number, right? B raised to power 1 means b multiplying itself once, which will still give you b. So that means that the log of b in base b is 1. So any log in its base will give you 1, and that is log of the base. So kindly note that any log in its base is 1. All right, so very quickly, we're going to pick 2 WAEC questions and then see how to apply these laws. You can actually have a question whereby you can apply up to 3 laws to solve just one question. All right, so that is the more reason why you need to know each law, so that when you see a question, you will know which law am I to apply. So please watch out for my next video, because in my next video, we'll be looking at change of base and then equations in logarithm. So very quickly, let's solve 2 questions applying these laws, then I'll give you one to try out. In base 10 minus 2 log 5/9 in base 10 plus the log of 100 over 243. So you will see that for me to be able to apply this law of logarithm in solving these questions, that they are all in the same base. So if they are not in the same base, you cannot apply the laws. It's just like saying, can I add x and y together? Of course, they are not from the same kindred. All right. Okay. So now, seeing this minus sign, what comes to my mind should be division law. All right. So that means I can actually have it to be, these two will go back to this place. All right. So that would give us the log of 75 over 10 in base 10 minus the log of 5 over 9 squared plus the log of 100 over 243. So since we have subtraction, let's go ahead and divide. So we'll have the log of 75 over 10 divided by 5 squared will give us 25 over 81. So let's finish with the first two terms, then we'll bring in the last one. So this is equal to the log in base 10 of 75 over 10. So if I change division sign to multiplication, we would have 81 over 25. So 25 into 75 will give us 3. And then if we check the numerator and the denominator, nothing else can cancel out. So we'll have 3 times 1 will give us 3. 3 times 8 will give us 24 in base 10. All right. Okay, that's actually over 10. All right. So now we bring in the third term. So we have the log in base 10 of 243 over 10. So plus sign means we will multiply. So recall what I said earlier when we were treating the laws, the first law, that you can actually have questions on addition and you will have to change it to multiplication. It mustn't be a question in multiplication for you to add. All right. So this is over 243. So what will happen? We have the same number here and here, so they will cancel out. And then 10 will divide 100. So we will have log 10 in base 10. Now I'll be counting the number of laws we have applied in solving this one question. So imagine if you are not conversant with the laws, you may get stuck or do the wrong thing. So getting this, are we done? No, we're not. Remember the law that says that any log in its base, a log in its base is equal to 1. So log 10 in base 10 is 1. So our final answer, can imagine this huge expression. The result is 1. Okay, so very quickly we look at the next question. We have log 3 in base 9 plus log 243 in base 9 plus 2 log 3 in base 9. So look at this, you remember what we did in the first question. So these two will go back here and that will leave us with log 3 in base 9 plus log 243 in base 9 plus we would have log 3 squared in base 9. Alright, so we have plus here, that means we will multiply. So we are supposed to multiply everything out, but then we have log 3 in base 9, log 243 in base 9, and this is log 9 in base 9. So do you remember that anything raised to a log in its base rather is equal to 1? So this last term is giving 1 already. Okay, so that would mean the log in base 9 of 3 times 243 . So this is 1 already, because the log in its base is 1, right? Okay, so 3 times 3 will give us 9. 3 times 4 will give us 12, right? 2 carry 1. 3 times 2, 6 plus 1, 7. So we'll have the log of 729 in base 9 plus 1. Let's not forget our 1. Okay, now this 729 is looking big, it's looking huge. In fact, it's not even looking, it's huge. So, but let me see if it's a multi. Let's see, 9 here will give us 81. 9 into 81 will give us 9. 9 into 9 will give us 1. Okay, so this would become the log of 9 in base 9 to the power of what? To the power of 3 plus 1. So you remember the product law. If you remember it, you will know that this 3 will come down here, and that will be 3 log 9 in base 9 plus 1. Remember that any log in its base is 1. So this would be 3 times 1, right? Plus 1. And what will our answer be? We have it to be 4. Simple as ABC. All right, please go through these 2 questions again and try this for me. And when you are done and everything is clear, please try this question for me. And then drop your answer in the comment section.